So learners, hopefully you have liked our first video. Now this second video of the playlist is exclusively for you. This one deals with motion in 1, 2 and 3 dimension. So go and check it out and enjoy. In this video, we will be dealing with the motion in 1, 2 and 3 dimension, and we will be solving the questions that have appeared in WBJEE in the last 5 years. No questions came in 2020, 2022 and 2023. This question came in WBJEE 2019. The question is regarding a motion of a body in a straight line. It was moving under the action of an engine with a constant power in a straight line, and it was starting from rest. So the initial velocity was 0. The question was asked to find the relation between displacement and time. There were 4 options. The first option was a quadratic equation. The second option is also a quadratic equation but with one constant. The third one was a equation containing time having the power 3 by 2, and the last one was having a linear equation. Now we have to do this by using calculus. So let's see how we do this. So let's understand the limits first. Initial velocity is u, instantaneous velocity is v. Initial displacement is 0, which is always true, and the instantaneous displacement is s. The initial time is 0, instantaneous time is t, and we have taken the instantaneous acceleration as small f. So the force acting at any instant on the body will be given by capital F equals to mass into acceleration, which is m into f. As we all know, the power is constant and the power is given by the product of force and velocity. So we have put m into small f in terms of the force, and the velocity is kept as v. That is equal to a constant. Now we know that the acceleration can be written as derivative of velocity, which is dv dt. So f is replaced by dv dt and small v is there. So now if we rearrange the term, it becomes v dv equals to k by m into dt. Now we have to perform integration on both sides, but we should be very careful about the limits. On the left side, the velocity, the limit will be from 0 to v, as the initial velocity was 0. Also on the right side, the limits of time will be from 0 to t, as the initial time was 0 as usual. So on integrating, we get the value of v as root over 2k by m times t to the power half. But we have to calculate the displacement. So v is replaced with ds by dt, and we cross multiply dt to the right side. Again we have to integrate, and this time we should be careful about the limits too. The limit of s should be starting from 0 and up to s. The limit of t should be from starting from 0 and ending at t. And on performing the integration, we can see clearly that displacement comes to be some constant multiplied by t to the power 3 by 2, which clearly shows our answer is going to be option C. Now the question in WBJEE 2021 is quite interesting. A graph is given which is basically an acceleration versus distance graph, which we do not see often. In this graph, it is told about the initial acceleration after a distance of 20 meter and the final acceleration after a distance of 35 meter. The initial velocity is given as 5 meter per second, and it is asked to find out the velocity of the particle at x equals to 35 meter. In this type of question, where the shape of the graph changes for a period in which the acceleration is variable, we have to use integration and differentiation. But for the part at which the acceleration is constant, we can directly use the equations of motion. So here also we have to divide the entire thing into 2 parts and then proceed. So let's see. So the entire motion can be divided into 2 parts. The motion from A to B, which is the acceleration increases uniformly from 5 meter per second square to 10 meter per second square with distance changing from 0 to 20, and the motion from B to C, where the acceleration remains constant at 10 meter per second square and the distance changes from 20 to 35. So we need to find out the relation between acceleration and distance, especially during the period A to B. So we use the concept of straight line. We find out the equation of straight line AB by using the coordinates of the point A, which is 0, 5, and the coordinate of point B, which is 20, 10. And we get the equation as A equals to 5 plus 0.25x. Once we have got the equation of acceleration connected with the distance, we now use the differential equation of acceleration. We know acceleration is rate of change of velocity with respect to time. So acceleration A can be written as dv by dt. Now we multiply a term dx by dx with this dv by dt and rearrange it in such a way that dx by dt is multiplied with dv by dx. The first dx by dt becomes v. So acceleration can be rewritten as v dv by dx. This relation is very important and to be used mandatorily when we are dealing with problems where acceleration and distance is in question. So v dv by dx, which is acceleration, is equal to 5 plus 0.25x. If we rearrange the terms such that everything related to v comes to the left side and everything related to x goes to the right side, and we integrate with the limits of velocity from 5 to v because the initial velocity was given as 5. Now on the right side the limits are set to be 0 to 20 because initial distance was 0, which is clear from the graph, and the final distance is 20 at the point B. So once we integrate with these limits, we get v square equal to 925, and which we will use in the next part. This v represents the final velocity at the end of the stretch AB. So this v is basically the velocity of the object at the point B. So the initial velocity at the point B is root over 925 meter per second, and let the final velocity at the point C be w meter per second. The distance between the point B and C is 35 minus 20, which is 15 meter. And the acceleration during this period from B to C is constant. So we will be using the equation of motion v square equal to u square plus 2as instead of using any differential equation. The differential equation can also be used and we will get equal answer, but that will be lengthy. So we will be directly using the equation of motion. Now if we use the equation of motion v square equal to u square plus 2as, we get the final velocity at the point C, which is equal to 35 meter per second. And that will be the answer for this question. Now coming back to the question that came in 2021. In it, the mass of a particle was given and the potential energy was given as a function of displacement, which is x. So V was given as ax into x minus 4 joule, where a was a constant and 4 options were given. It was our task to mark which of them was correct. So let's see each of the options one by one and see which one of them are going to be correct. In this question, we will be mainly using the relation which tells us that conservative force is equal to negative of the potential energy gradient, or in other words, F is equal to minus dV by dx. So first, let us simplify the expression of V. We will multiply in that x, so it becomes a into x square minus 4x. Then we do the differentiation of V and put a minus sign in front of that to get the expression of force, which comes to be minus capital A times 2x minus 4. So this force depends on x and hence clearly is not a constant. So option A is wrong. So if we rearrange the expression of force, it becomes F plus 2 capital AX equals to 4. But the equation of any simple harmonic motion is going to be force plus some constant multiplied by displacement equals to 0. So f plus kx equals to 0 should have been the equation of a simple harmonic motion. But here the equation is f plus some constant into x is equal to another constant. So this is clearly not an equation of simple harmonic motion. Hence option B is also incorrect. Now to check the third option, what we do is first calculate the acceleration, which is force divided by mass. Now we see this acceleration becomes 0 when we put x equals to 2. So that means at x equals to 2, the acceleration is 0, which implies that the velocity will either be maximum or minimum. But the question is it maximum or minimum? So what we do is we differentiate acceleration and we find that it becomes minus 2 capital A divided by m. Now A and m here are constants which are positive. So dA by dx is clearly a negative term. So the derivative of acceleration is negative, or in other words, the double derivative of velocity is negative. So double derivative of any function is negative. That means the function is going to be maximum. So the velocity will be maximum at x equals to 2. So option C is going to be correct. As we have shown earlier that here the force doesn't represent a simple harmonic motion, so a question of period of oscillation does not arise. So option D is also incorrect. So hopefully you have liked this second video of the playlist. If you have not watched the first video, which was on vectors, please go into that video and watch it. It will be very useful to you. The link of that video is given in the description. So we will be bringing to you the next chapter in the next video, which is going to be launched very soon. So stay tuned and like, share and subscribe to our channel and enjoy amazing videos in physics and maths that is going to help you, especially in the last minute of your exams.